Hi. In this tutorial we are going to take off the training wheels and crack a real program. This program has a time restriction, and after this time, it will not work anymore. We are going to patch it to think it is registered. The target is included in this download. I am not stating the name of the program, as the purpose of this tutorial is not to get a cracked program but to learn how to do it. Like all commercial programs, if you plan on using them, you really should consider buying it. People put a great deal of time into apps and they deserve to be compensated. In an attempt to not make this series about getting cracked software, I tried to get a program that no one would really want, so I downloaded this app, which had the least amount of downloads. To be totally honest, after cracking the program in this tutorial, I liked it so much I paid for the registration and now use the app legitimately. Just goes to show you can judge an app by its test downloads. Let's study the app first. Go ahead and install the app. After completion, the following screen comes up. Let's run the app and see what we're dealing with. Well, that's not very nice. Here we notice some strings that could be a potential help. Unregistered, evaluation, registered, etc. Click OK and we get to the main screen. Notice it says unregistered at the top in the title bar. Usually, another place I look in an app is the About screen. A lot of times it will contain strings and/or ideas for reversing. During this phase, we are looking for keywords, recognizable method calls, stuff like that. The more you do this, the more clues will jump out at you. The next thing I usually look for is if there's a way to enter a registration code. This is a good starting point for penetration if the search for strings trick did not work, and here we see an option to enter a registration code. Let's try one and see what happens. Click OK. I never seem to get this part right. Alright, we have a pretty good idea as to what we have at our disposal, so let's load it up in OLLY. Well loaded up in OLLY. You may notice that this looks a little different. There seem to be an awful lot of call instructions. I think it's written in Delphi. Delphi uses tons of calls all over the place. Maybe in future tutorials we will get into that. Let's try our string search. Right click. Choose search for all referenced text strings and the search window will open. And right-click. Choose Search for Text, and the Search for Text window opens. Now, I noticed that the word registration and registered were used a lot earlier, so let's search for them. Usually in this case, as my first search, I will search for regist, as this covers both registration and registered, and I've never gotten a false positive from this. Make sure case sensitive is unclicked and entire scope is clicked and hit OK. Notice that this occurrence is just the actual data of the first hit we had. This is because the first hit was where the string register automation was pushed onto the stack, and the second occurrence is the actual data in memory for the string register automation. You can tell because there is no instruction for it in the second column, and instead it says ASCII. Most strings you come across will have two versions of it, the one where the string is accesses, and one where the string actually resides. If you hit Ctrl L, we will come to another not very promising looking string. Keep hitting Ctrl L until we come to the following. Now that looks a lot better. It would appear that at some point in the program's starting up sequence, it checks if we are registered or not, and depending on the results, it fills the title bar of the window with either the registered or unregistered string. This is a good place to start. Double-click on the registered version and we will jump to the code. First, notice that we can see where the string is used at address A96135, and we can also see where the string is stored in memory at address A96158. Secondly, notice that both strings are in the same method and a conditional jump is above them. Click on the conditional jump at address A96131, we can see that if the result is equal, we will jump to the unregistered version of the string. We obviously don't want this to happen. Let's place a BP on this G instruction and start the app. Ollie will break at this line and you will notice that we are going to jump to the bad boy. Let's change that and run the app. Ollie will then break at this same line again, wanting to jump to the bad boy. Let's change it again by zeroing out the 0 register and hitting run. This will happen one more, and clearing out the 0 flag, we finally get some feedback. So that didn't work. So patching that one check does not make us unregistered, although if you click OK and zero out the flag one more time, you will notice that it does take off the unregistered title of the main window. Now at least we know we're on the right track. What we are going to have to do is step this up to the next level and investigate a little further. Restart the app so that we break at our breakpoint and let's investigate a little more. There is no call before the compare, but before the G instruction there is a compare at address A9612A. So, based on the outcome of this compare, we are either registered or we're not. X plus 1620 is just a memory address, in this case a global variable as it starts with DS. What we hope is that this is the only check that the app is registered or not. If it is not, we will need to go find out where else the app checks for registration status. Clicking on the compare instruction shows us what X plus 1620 is. So right-click on this address and choose Follow and Dump. Here we can see the address that is checked for being registered or not. It is the first OO at address 2BC209C, on my computer at least. That means that if the contents of this memory location were to be anything other than 0, this routine would assume we were registered. This also means that there are probably other routines in the app that check this memory location, which is why the main screen shows registered while another part of the app knows we're not. Since we only bypassed this routine's natural flow after checking the memory contents, any other routine that checks it was not bypassed. First things first, let's set this memory address to non-zero so we know that at least this routine will always work the way we want. Click on the OO in the dump, at 2BC209C in my dump, right-click and choose Binary, Edit. Let's enter 01. And notice it has been updated in the dump. Now go ahead and run it till we break again. You will notice that the memory contents have changed back to zeros and that we are now going to jump to the bad boy again. This means that somewhere in the app, a secondary check was done that reset our registered flag back to 0. What we need to do is find where this is being set and make sure it doesn't happen. To do this, we want to set a hardware breakpoint on this memory location to tell Ollie to stop whenever the app writes to this location. We want to choose write because somewhere a 0 is being written to this address. Right-click the compare and choose follow and dump again as Ollie has reset the dump window. Binary edit the first memory location to 01. Notice it's now at a different memory address. Then right-click on the first value in the dump that we edited and choose breakpoint, hardware, on write, byte. Now run the app. Ollie will break at our normal breakpoint again, and you can see that the 01 value we entered is still there, so far so good. Run it again and Ollie will break in a new section. If you look in the bottom left corner of the OLLYDBG window, you will see that we broke on our hardware breakpoint. Now, let's study this code. The first instruction compared DL with the memory contents of our edited address. If they are equal, we jump to A99252, which simply returns. If they are not the same, we store the contents of DL onto our memory location. We already know that DL equals 0 because we saw the memory location change from our 01 back to 00. So this is basically another registration check, and if it fails it puts a 0 in the registered, not registered flag. Okay, now let's think for a minute. This routine is called before our original break. This routine checks if we are registered or not and puts a 0 in the memory address pointed to by x plus 1620 if it is not, and a 01, or any non-0, if it is. Then our old routine is called the one that either prints registered or unregistered on the title of the window based on if this memory location contains a 0 or 1. So if we make sure a 1 is put into that memory location every time this routine is run, then any other routines will check that memory location and see that it is a 1, and think that we're registered. What would happen if we just change this routine to always put a 01 into the proper memory location? Let's try it. Now the next question is what's the easiest way to do that? Well, we have the memory location already being populated with something, DL, at address A9924C, so we could just change the DL top a 1. The problem with this is that changing the DL to a 1 will add a byte to the length of this instruction, and this will overwrite our return statement. What about if we replace the compare and jump instructions and instead just load 01 into DL? That way, on the last line, DL will be moved into our memory location. So here's what we do: highlight the two compare and jump instructions. Then right-click and choose binary, fill with nups. Which gives us this. This step isn't required, but it makes it a lot easier to see what you're doing. Now click on the first nup at address A99244 and hit the space bar. This will bring up the assemble window. Then enter MOVDL 1. Click assemble. Now, whenever this routine is called, a 1 will be put into the memory flag instead of a 0. Since we are still paused on the first line of this routine, you can single step to see DL being loaded with 1, and then the 1 being put into the memory address. You may need to go to the proper address in your dump as Ollie has probably reset it again. Now run the app and Ollie will break at our original breakpoint. Go ahead and keep running and we will break in our modified registration check routine, and it will put a 01 into our address again as we planned. This will go back and forth a couple times until finally we are now registered. Go ahead and run the program, open a demo file, and Ollie will break several more times in our registration routine, but each time it will go the right way. Soon you will get to the main screen. And you will see that we are still registered. clicking on the About screen. Congratulations! You have patched your first crack. Don't forget to save it back to disk. Open the Hardware Breakpoints window, Debug, Hardware Breakpoints, and click the Follow button on our BP. That will take us to our patch. Highlight everything we changed, right-click and select Copy to Executable. Right-click in the new window and select Save to Disk. Save it as the original file name. Now quit Ollie and run the app and experience it is all at registered glory.